Let's review the supervised machine learning training tasks we need to perform. First, we will split the prepared DOT data into two sets of data, one for training and one for testing the trained model. Typically, about 70% of the data goes into the training set and about 30% goes into the testing set. Then we will train the algorithm with the training data. We'll hold the test data aside for evaluation. This training process produces a trained model with parameters based on the training data. But I bet you're thinking, what about the test data? We only use the training data to train. What are we going to do with the test data? You're correct in questioning this. Do you have any thoughts on why we split the data and then only used one of the sets of data? If we used all of the data to train, the produced model would train to both training and test data sets. Since data drives the training model, this additional data would impact the workings of the model. Also, when we evaluate the model with the test data, it would likely falsely perform well since the model has seen the data before and knows about the test data's biases. But the model could perform poorly when used with real-world data that had a different set of biases. To prevent us from being lulled into thinking that the model performs better than it really does, we hold the test data aside and only train with the training data. In the next module, we'll use this test data to evaluate the training model. But for now, let's focus on the first two steps, splitting the data and training the model. But before we get started training, we need to select the features, i.e. columns, that we will train with. Since the data drives how the model is trained, we want to ensure that we train with only the minimum number of features. This makes the training go faster and often more accurately. We can look at the data and reason about the context of the problem to make our selection. For airline flights, we see there are some columns that stand out as good candidates for explaining why a flight would be delayed. Origin and destination make sense since airports have certain features such as a history of bad weather and few runways that make them more likely to have delays. Day of the week is selected because, as anyone who travels knows, there are certain days of the week that are worse for traveling. This is often because the high volume of passengers and departing and arrival flights create a perfect storm for delays. Carriers have how shall I put this, certain patterns of behaviors that affect delays. These include overbooking, a history of late departure or arrival, and other scheduling issues. We also selected departure time block. Departure time can affect delays because traffic, weather, and passenger loads vary throughout the day. And a late departure means a late arrival. Since leaving at 7:30 is not much different than leaving at 7:31, but may cause the time to be treated independently by the algorithm, we use departure time block. Departure time block groups departures into 1 hour or longer segments, such as 6 a.m. to 7 a.m., 7 a.m. to 8 a.m., etc. And finally, we need to include arrival delay 15. Since this is supervised machine learning, we need to include what we are predicting as part of the training data.